Dear students, today we will learn about distributed systems. So distributed systems are software units that are executed as processes on different computers. So for example, if you have one complex problem that need, for example, 100 of hours to be executed on one computer. So one of the strategy is that you distribute the load of those 100 hours to 100 computers, and those 100 computers collectively working together can come up with the execution of such a huge and complex task within 1 hour. So this is one of the possibility. So such kind of things are studied under distributed systems. So which softwares are distributed? With the networking technology's success, global information retrieval is being distributed. So for example, when you make a query on Google, so all of the data is not residing at one particular server. So Google is indexing huge trillion of web pages, and those web pages are distributed in different servers residing in the different parts of the world geographically. And then those parts are joined together based on the user query in a distributed way. Then company-wide accounting and inventory systems, computer games, even the software controlling the network infrastructure are designed distributedly. How it has evolved? In the start, when computer systems were built, every distributed system was built from scratch. However, nowadays we have basic infrastructure available, and on that basic infrastructure, different vendors and different users can build their own distributed system platform applications. Those do not need to be developed from scratch. What type of distributed system and distributed system environments or architectures are available today? We have cluster computing, grid computing, and cloud computing. Cluster computing is many independent computers work together to provide computation and services. And cost of individual machines and the connections, the network connectivity, even if you add all of such cost, that cumulative cost is even less than the cost of a high-speed supercomputer, which can be replaced by multiple computers connected using cluster computing. So advantages are low maintenance cost, provide high availability, and load balancing is relatively easy. It provides high availability because if one supercomputer has fault, so this means that you cannot execute your code. However, if you are using cluster computing and your code is distributed, at least the part of your code that is distributed to some computers which are active and alive, so that results can be combined together. And if only one or two computers get problematic, so those computers can be corrected afterwards, but your overall availability is high. And similarly, you can balance the load into different computers. Then there is a term known as grid computing. So these are loosely coupled than clusters, but they still work together to accomplish the large task and involve specialized software. So normally there is a specialized software which is installed on all of the computers who want to be part of the grid. And here is a concept of volunteer computing as well. So for example, if you have a computer and that computer is not being used by yourself for a certain period of time, you can volunteer yourself or your computer to a grid. And you can say, okay, for next 10 hours, my computer is available and I volunteer my services that you can use my computer to solve any complex problem. And in such a way, millions of computers are connected together. So the software that is being installed is one of the software is University of Wisconsin's Condor software, or there is another software of Berkeley Open Infrastructure for Network Computing, which is also known as Bionic. So the grid computing are softwares are installed for volunteer computing, and when the machine is free, it can offer its services. And then there is a third type after cluster and grid computing, which is known as cloud computing. So huge pools of shared computers on a network can be allocated for user by clients as needed. For example, Amazon Elastic Compute Cloud allows clients for rental value of virtual computers by hour. So you can store your data on their cloud and you can pay them hourly basis, monthly basis, and whatever the terms or conditions. Then similarly, Google Drive and Google Apps are also examples of cloud computing. So cloud computing is reasonable. It reasonably guarantees about reliability and scalability of the machines. So it is not your headache that whether your machine or server is up and running. So it is the headache of the cloud. So they normally have very sensitive infrastructure and very up-to-date mechanisms that make them reliable and scalable. However, there is a privacy and security concern. So your data can be stolen by some other user. So these type of things are being researched by researchers around the globe. So if we summarize today's topic, we have learned about how the softwares are distributed and how they are studied under distributed computing. And we have learned three architectures: cluster computing, grid computing, and cloud computing.